Hello, welcome back to Cracking the Cryptic. Simon is still suffering with COVID, as you can see on his videos today. Luckily I'm not, so there's no excuse if I am struggling to solve puzzles. There we go. Now, I'm going to be doing a puzzle by Chile today, and if you'd asked me, I would have said, yeah, we've done Chile before, probably a few times. And I looked at the catalogue spreadsheet, which you can find on a link below the video in the description field. Turns out we've never done a Chile puzzle as far as I can see, and I'm astonished by that. This has been one of the most delayed debuts. I know Chile featured in a collaboration of some sort. Was it on Patreon or was it on the channel? A collaboration of quite a lot of people. Maybe some individual puzzles within a Patreon. Yes, I reckon the Roman treasure. He or she was involved in that, I reckon. But anyway, this is, I think, the first solo puzzle on the channel by Chile, and we are delighted to feature it, especially as it's an equal sum lines puzzle. And that's a perfect cue to tell you about our July Patreon content by Joseph Neymer, no less. It's a series of at least a dozen equal sum lines puzzles. They are absolutely fantastic, I can tell you that for definite. They're really interesting, not variants of equal sum lines, but equal sum lines normally with an additional variation, and they are absolutely fascinating. Strongly recommend you becoming a Patreon, or just making sure if you are already a Patreon that you're ready on the 1st of July to have a go at those puzzles when we launch them. They're really, really good. Along with all our other Patreon content, along with all our apps, along with Sven's SUDOKU PAD. They're all really, really good. They're all on links under the video. As is our merchandise, and you are welcome to engage with us in any way you like at all. But the rules of this puzzle, let's do that next. They are normal Sudoku rules apply, and there's only one rule. The blue lines are equal sum lines, and that means the sum of the digits on a line within a particular region must be the same for all of the region the line passes through. So if we take this line, it goes through two regions, and the sum of the digits in box 3 are the same as that cell in box 6. Now, there's an important question. I think it regards those cells, actually, and those, but the sum applies to each individual visit a line makes to a region. So that is the sum of those two, and those two are the sum of that on that line. I don't think any other lines visit the same box twice. Different lines may have different sums. I'm tempted to say, of course, but I suppose I haven't actually proved that that's necessary here, but I'm sure it is going to be the case that different lines have different sums. Some may have the same sums. Is that English? Too many sums in the sentence. Anyway, let's have a go at this. Do try it on the first link under the video. That's above all the links to all the exciting things I told you about, but I'm going to start now. Let's get cracking. And this central line, the huge line, has a 3-cell component. That's great. That means we know that those 3 cells must add up to at least 6. And this line has single components. It's got 1, 2, 3. It's got 5. They're all the same, aren't they? They're all 6, 7, 8, or 9, but I think possibly more importantly, they're all the same. So let's make them purple, because that's the same digit replicating throughout the grid. Now there's going to be another purple up there somewhere. I was about to say that proves purple is not 9, but it doesn't prove that at all, because although this cell can't be a 9, because those two add up to a single cell there, this one could be, because that's 2 cells adding up to 2 cells. So I better not be rash with my judgments here. I loved the comment on yesterday's video. Somebody said in one of the gas puzzles, Mark goes too slow by going too fast, which was very funny. Anyway, purple. One of these is purple on this 4-cell segment, which has a 2-cell line there. Oh, okay, that's quite interesting straight away. I was hoping, for some reason, I'm desperate to prove purple isn't 9, it seems. I was about to say, I don't think purple can be 9, because this total is 15, and then you can't put a 9 here, but you can. That could be 9, 1, 2, 3 with an 8, 7 there. In fact, I'd love purple to be 9 because we'd know all about this line then. But I don't know that purple's 9, so that's no good. This cell is on a 3-cell line, so that is 6, 7, 8, 9 and not purple. This cell is on a 3-cell, is equivalent to a 3-cell line, so that's 6, 7, 8 or 9 and not purple. This cell is on a 3-cell line, or has a 3-cell component, so that's 6, 7, 8 or 9 and not purple. Crikey, there's a lot of those around, that's probably significant. These five are the same total as these 2, which can't be more than 17. And these 5 have to be at least 15. So the total of these 2 cells is somewhere between 15 and 17. So that is 6, 7, 8 or 9 as well, because that would have to be. So it's another non-purple 6, 7, 8 or 9. These ones have to have 1, 2 and 3 in now to add up to no more than 17. 1, 2, 3, 4, 7 is the highest digit you could get, or 1, 2, 3, 5, 6. So that doesn't quite mean this isn't purple yet, I don't think. Oh, it does for a very pretty reason, because they would both be purple, and then these 4 digits would effectively add up to the same as that one, and that's not possible. Oh, that's lovely, yeah, because those 2 add up to some number between 15 and 17, and these 5 add up to the same. Take those out of the equation, and you're left with those 4 adding up to that, which is not possible. So that is not purple. Bingo. That is blank. This is purple. And that tells us very little up there, but it gives us a purple in one of those 2 cells. Now this can only be purple if it's 6 and this is 9. Then we get a 1, 2 pair there. That puts quite a lot of pressure on this. We've got a 1 or 2 there. This now has to add up to at least 8 if this is a purple 6. Oh, which it can't do. Hang on. That can't work. If this is a 6, this has to be 1 or 2 to allow that to be a Sudoku number. And if this is a 6, what I'm saying is if this is purple, it has to be a 6. That has to be 1 or 2. But this 6 is seeing a 1, 2, 3 set here. So purple is not 6. That's something proved. I mean, it's hardly surprising, but it might be useful. It doesn't affect this. Oh, it does prove that purple is not on this line, because purple is now 7, 8 or 9. So this is purple. So now we've got a little X-wing on remaining purples down here. Oh, and purple is, yeah, here we go. This is a 3-cell line as well. So purple can't be on that either. Now it's not 6. So that is not purple. This is purple. And we have all of our purples purplified to the purpliest purple possible. And they're all 7, 8 or 9. Now, what's that doing down here? These 3, yes, look. I'm going to use different colours. Those 3 are the same as the total of those, because this is the same as the total of these yellows, and these blues are the total of these yellows. So the minimum there is 1, 2, 3, 4, 5, 15, plus a 7 there, and a 1 there is 23, and the maximum for these is 24. So these add up to 23 or 24. They are either 986 or 987. Is that right? This is right. Let me just check this maths. The minimum there is 15. The minimum here is now 8, thanks to this purple. 16, 23. So these must add up to at least 23, and they definitely include 9 and 8, and now purple is 7. That has to be right. I'm going with it. Purple, you are 7. Why has that? Let's go into the colours and highlight that again. There we go. Purple, you are 7. Bingo. We're away. Right, now, that is a 1, 2, 4 triple. These have a 3 on them. These other 6, 7, 8, 9s are not 7. This is now 6, 8, 9, in fact, down here. Even that one. These add up to 23. Oh, including those. Hang on. 23 in blue means yellow is 23. Those have to be 1, 2, 3, 4, 5 because they are in the row anyway, and that becomes a 1. So there we go. Thank you, yellow and blue. You may now depart the stage. Sorry, I've lost control of my pencil marking. There is a 1 down here. And that is a 7, and it's purple. I've really fallen apart on the colouring. I accidentally hit the back key and it messed me up. Anyway, 6, 8, 9 here. Now, can this be 6? Yes, that could be 2, 3. Yes, whichever. Okay, that can be 6 with 1, 2, 3. It can be 8 in 2 ways, and it can be 9 with 1, 5, 3. So whichever way it's going to work out, it's going to make this work out. I should not have highlighted 2. Corner mark 2. I meant to say 1 has to be in those cells. So I don't think I can do any more in the bottom row, weirdly, until we get a bit more traction on that one, maybe. But what can I do up here? Now, this can't be 6, because these add up to at least 15. So it's 8 or 9. These are either 3, 5 or 3, 6. 7. Ah, these add up to 7. Oh, but I don't know what those add up to. Oh, this is a whole... Okay, these 6 cells, which now add up to at least 22, are the same as the total of these cells. So these have to have a 9 in now. You can't be 7, 8, 6, or these would be 21, which is not possible once a 7's in them. So that's not a 9. This is now either a 2, I don't know, okay, that's either 6 or 8, but there's a 9 in those. What else do I know there? I've got a 1 there and a 1 there. There's definitely a 1 in those cells. That's not very helpful. Ooh, there's not many possibilities for a 1 on that line. Oh, 1, 2, 4 here. So that is 3, 5, or 6. Oh, and these add up to that. Ah, looky at my cookie. Those 6 cells add up to a minimum of 21. And those 3 add up to, I should have spotted this earlier and didn't. Those 3 add up to a maximum of 24. Oh, hang on. We can't put 9 in those cells. So 9's in one of these 2. 7, 1, 2, 4. I think this is doing a lot of stuff and I'm just not quite understanding it. Right, this is now either 3, 5 or 3, 6 because that can't be more than 9. So I've got a 1, 2, 4, 3, 5, 6. Well, I've already had the 1, 2, 4. I've now got a 3, 5, 6 triple. That is 8 or 9. This probably can't be 6. No, I don't know that. Oh, no. Okay, I was talking absolute tripe earlier. I claimed that these 6 cells were the same as the total of those 3. I didn't use that then, and it's a good thing I didn't, because it was not true. Let's go back to yellow and blue. It's those 8 cells are the same as these 3. And those 8 cells always had to be. This is the break-in for the puzzle, and I missed it. Those 8 cells are 1, 2, 3, 4, 5, 6, and at least 1, 2 that is 24. And that's the only thing then that these can be is 7, 8, 9. Right, well, sorry about that, people. So that's a 1, 2 pair, definitely. I'm in the wrong modes all the time today. Okay, so that's a 1, 2 pair. This now is 5 or 6, as this has to be 8 or 9. Yeah, we knew that anyway, because there had to be a 3 over here. So I can't resolve those anymore. Let's get rid of the yellow and blue colouring. I think it's served its brief purpose, and it should have come out ages ago, but it's come out now. Now, 8, 9, 7. So the maximum for those is, well, it's 9 actually because of that. Where do 9 and 8 go in this box, please? Not on this line, because they'd add up to at least 11 there. Not on this line, because it adds up to 7. So they're both in these cells. Is that not going to make a 9-8 pair there? No, not necessarily, because one of them can be there. I think it makes these a 9-8 pair. Yes, it does. Yes, it does. 9 and 8 there means 9 and 8 can't be here. They clearly can't be on 7 lines, so that is a 9-8 pair now. And all of these single cells have now become 8 or 9. Apart from that one, which is 6 or 8, weirdly. Okay, this is good. This is good. We're still doing stuff. Now, those two, 15 or 16, is the total of those 5. So they must include 1, 2, 3, and 4. So this is either 9, 8, 6 or 9, 8, 5 down here. In fact, no, that doesn't have to be a 3, 4 pair because it could use whichever of 5 or 6 is in use in these. Oh, okay, this is an 8 or 9. That's a 7. Right, in this box, 7, 14, either 8 or 9 there is 22 or 23. Given that the box total must equal 45, because you know this secret, then this total is 22 or 23 as well. What's this? It's got a 1 on there. Don't know. I'm quite annoyed I don't know this total yet. Up here, these are from 5, 6, 8 or 9 because 1, 2, 4, 3 are all used there. So this total is at least 12. And it could, well, it can't be 16 because that would have to be a 9, 7 pair. So that's not a 9. If it was 8, 7, that would be a 6, 9 pair, which would fix this. But the trouble is it could be 13 or 12, and that's got a lot of options. Now, I haven't looked at this. Oh, 1 is looking up at that. Well done, Mr. Stormtrooper. You've completely missed all the Rebel Alliance running through. We get a 1 in one of those cells. Come on, it must do more than that. Oh, well, there you go. Sad news for the Stormtrooper. Even when he spots something, it's not worth anything. 2 up here. And a 2 there. Yeah, you can't put a 2 on this line because 12 is the minimum. Right, so that's a 2. So maybe the Stormtrooper was worth something. That's not a 2. I don't think it is worth much. 9 and 8 are there. 7 is there. That can't be a 1. That can't be a 3. Oh, there must be more that's coming from this. Come on. If you can see it, just shout a bit louder and I expect I'll hear you. Now, there's no 1s on this line, but it's not so interesting in an equal sum line because you're just trying to balance the 2 bits. I don't know. I don't know where I'm meant to be looking. I can't tell at all. This equals 8 or 9. This equals 7. That feels like the next place where we ought to be making some progress. 1, 3, or 4. Maybe I can rule out this being a 6. Then this would be a 2, 3 pair. Have 1, 4, 5 here. Yes, that doesn't work. You can't have 1, 4, 5 here because this pair of 7 would never have a fill. It couldn't be 1, 6, 2, 5 or 3, 4. That's extraordinary. So that can't be a 6 for a very strange reason relating to that bit. So that's an 8. Now that still doesn't tell me whether this is a 2, 5 or a 3, 4 pair, but it does tell me this is a 6, 9 pair. Oh, it doesn't tell me anything about this. Maybe it does. These now add up to 8, and those add up to 7. That's 15. So that's 1, 2, 3, 4, 5, and this is 6. That's what it tells me, and that is quite useful. Because now I know this is a 5, 8, 9 triple, plus 7 there is 29. These add up to 16 to make the total up to 45. That's the same as the total of these, and that's a 9. That's an 8. Right, now in the central box, 9 plus 7 is 23. Those add up to 22. I keep looking at those. It keeps not being any use. Classic. This can't be 5, 2, so it's either 3, 4 or 1, 6. This can't be 6, 1, so it's either 2, 5 or 3, 4. 1, 2, 3, 4, 5. Don't quite have enough of those to catch a fish alive, but 2 in this column does have to be in one of those 2 cells, and therefore isn't in those. 5, 8, 9, 6, 7. That can't be a 6. This can't be a 5. Let's take out the corner marks. 1, 6 or 3, 4. Does anything resolve that? With this being 8 or 9, or this pair, this can't be 7, 2 or 8, 1. This is 6, 3 or 5, 4. 2 has to be on this line, so it's either 2, 1, 6 or 2, 3, 4. If it was 2, 3, 4, this would be 5, 1, and that would be 6, 8. If it was 2, 1, 6, not so obvious, but 8's up in one of these cells. Probably not interesting. 9's in one of these. Now, can that be a 9? Yes, 9, 6, 8, 7 works. Actually, 9 works with a lot of things there. That's not a problem at all. These aren't related. 3 is there and there, so there must be a 3 up here in box 3. Oh, goodness me, this can't be 1, 6, 1, 7 or 1, 8, so that's not 7, 8 or 9, which is totally uninteresting. Or is it? That's 2, 3, 4 or 5. Can't be 2. Could it? Oh no, hang on, it could be a 6. Yeah, that's not all that helpful. 6, 9, 7. We need an 8 somewhere here, but I don't honestly know. Oh, we need a 9 in this box, and I can place that now, since I pencil marked that actually. Right. Now 8 is somewhere at the top here. Is that? Maybe I can work on this. This adds up to somewhere between 11 and 17. That's not very useful, or is it? The minimum here is a 2 here and a 3, 4 here. That's only 9. No, it's not very useful. 7, 8, 9, 1. Now there can't... Oh, we need a 6 in this row, and there's a 6 down there. That is a 6. So this is a 1, 5 pair. Okay, this is looking a bit more promising now. This, we still don't know. We know what it adds up to. Actually, that's useful. Since this pair adds up to 7, this adds up to the other pair that makes 7 and 8, 15. So it could be, well, it can't be 8, 6, 1 or 8, 5, 2. Okay, what I should have been saying is where's 5 in this box? That's the simple way. Given that 5's there, it's down here. That's a 5, 2 pair. This is a 3, 4, 8. This is a 2. That's a 5. Now something is happening here. Let's just get rid of all the pencil marking. Put in 1, 3, 4 there. Now, what is that doing looking north? Is it doing nothing? That would be distressingly depressing. 2, 3, 4 is a triple here. I'll take that. 6, no. 9. So 12, 13 or 17. They're very different totals. 12, 13 or 17. I don't know how to use that. 2. Oh, come on. Something must have popped open around here. These add up to 9. Now, 1, 2, 6 or 2, 3, 4. If they were 2, 3, 4, that's a 1. I've done this before. That's a 6, 8. Then that's a 5, 3. That becomes 8. This is a 9-8 pair here now. It's been that for ages. That gives me a 9-8 pair in the final column. That's not an 8 then. 8, 9, 2, 1, 7. These are from 3, 4, 5, 6. Is that useful? Maybe. What's going on this line? 12. 12. Oh, it would almost have to be 3, 4, 5. It doesn't quite have to be. Now, I still don't think this line's giving me anything. Let's just, no, I was going to reduce that to its possibilities, but I don't know what they are. This pair adds up to 7. I haven't looked at that at all. And for good reason, it's giving me nout. Oh, goodness me. If that was 6, 1, is that harder? I don't think it is. I mean, this 1, 2, 3, 4, 6 quintuple, I thought that was going to be really helpful, and it absolutely hasn't been. Oh, good grief. Still plugging away here. Now, come on. 9. That's an 8, 9 pair. That's been there for ages and ages. This is 2, 3, 4, 5 or 6. The maximum for these is 15, 6, 5 and 4. So that's not an 8. Yeah, that's okay. So that's an 8. That gets us something. That fixes 9 and 8 up here, and that's useful. That puts 9 here, 6 on the thingy, the equal sum line, 8 there. These don't need their pencil mark anymore. It's a 3, 5 pair. Are they resolved? No, they are not. 9, 6, 1, 7, 2, 8. So that's not a 6. These are from 3, 4, 5. This is not a 6. Now, 12 or 13 on this line. Six, 5. I mean, there seem to be quite a few ways of doing that, which is not what I wanted to see. Oh, 6 has to be in this, in these cells of this line. Then it's getting a bit more limited. 12 or 13. 12 would have to be 6, 4, 2, and 13 would have to be 6, 4, 3. No, 6, 5, 2 is also possible. Oh, bother. 8, 7, 9. So there's a 6 there, so there's no 6 here. There's a 6 somewhere here. That's not really all that powerful. Still haven't fixed the 1s. Oh, this is so close to being... I don't think we need many more deductions now. I'll say that, risking life and limb. There's a 3 there, so there's not a 3 here. Now, if that's... Oh, this is 3, 6, making 9. That's hardly a deduction, that's just noticing. So none of these are 6s. Now, this adds up to 12 or 15. If it's 15, we know this goes 9, 6. If it's 12, we can't use 7, 5, and we can't use a 3, so it would be 8, 4. That's 2 very distinct possibilities on that line. 4, 8, 5, 7. That would make that a 9. No, there's got to be a 6 in this row. That's the important thing to notice. Am I sure it can't be there? Yes, it's there. Yes, there's the 6. It is therefore 15. It can't be 12. Yes, it is 15. Lovely. Right, so that's a 5. That puts 5 there. Takes 5 out of those cells. Oh, what am I doing? Let's just put in 3, 4. There we go. That is a 9. For 9, 3, 6, 5, 7, 2. This is a 1, 4, 8 triple. No, we know where the 8 goes. Right, there's no 6 here, so there's no 1. That's a 2, 3, 4 set. That's a 1, 6 set. Now we can move into beast mode finally. Actually, look, 859 was sorting that out for ages. Well done if you spotted that. Extra points for you. And a dinosaur for me. 6-9 there, 5-1 there. This 3-4, but no, I don't know. We're going to come back to 2-5's been resolved. Doesn't sort out that at the top, but never mind about that. 2, 3, 4, 8. That can't be 5. Ah, look, 3, 4 pair. That's powerful. So this is now a 5, 6 pair. 11 versus 9. That has to be 2 less than that. So this is a 2 and that's a 4. Lovely, lovely, lovely bit of setting from Chile there. 1, 4 there. Those don't have a 2 and a 4 there. A 3 and an 8 now. Incredibly, that is still not done. This can't be a 2. So we need a 5 in this row. That's the point here. So that's a 5, 4 pair. And that is going to take out 4s in a lot of places. Excellent. So we get a 6 and a 1. That's 2 and 4. Yes, this has to add up to 4 without a 2 or a 4 in it. The even digit is a 6, therefore. 9, 5. Yeah, well, I mean, I'm sure there were things I wasn't spotting, apart from things I eventually spotted I wasn't spotting, if you see what I mean. But we are getting there now, and it's a very clever puzzle. Yeah, I've enjoyed that. Some hope indeed. A new hope was what I needed with my Stormtrooper scanning. And here we go. 1, 2, 4 to finish. And that is the answer. Lovely puzzle from Chile. Hope you had a go at that. That's really entertaining. Thank you for watching, as always, on the channel. And really hope we see you again soon. Bye for now.